and we are set to go. So welcome everybody. Hello. Yes, we're good to go. Oh, fantastic. We've got people from all over the place. Wow. Okay. A lot of people from UK. This is a pretty good UK time. We've got Shanghai, Indonesia, Perth, Saudi Arabia, South Africa, Nigeria, Holland, Pakistan, all over the place. Fantastic. Welcome everyone. It feels like it's been a while since we did one of those. It's only been a couple of weeks, I think. And thank you so much, Tim, for agreeing to do this. My name is Danielle Stein-Fairhurst. I'm a financial modelling specialist and Microsoft MVP based in Sydney, Australia, although as you can see, I'm not in my usual office. I just got back from Hong Kong late last night, which was a lot of fun. And I'm just visiting some family right now. And yeah, we're very excited to have Tim Jacks as our guest speaker today. So Tim and I met a while ago earlier this year at the
February.
Global Excel. Yes, just in February. It seems like it was a long time ago, at the Global Excel Summit in London, which is coming up again, which will now be, it's been moved to May. So are you coming to the summit again, Tim?
I will do, yes.
Fantastic. I look forward to, I'm definitely going to be there. So I'm really looking forward to that. So yeah, it's a fantastic event, the Global Excel Summit. So if you are anywhere near London, do not miss it. It's a great event. So hello, Tim Jacks. I will let you introduce yourself. Tim Jacks is a financial modeler based in the UK, and he's going to talk to us about dimensions in financial modeling, which I think is a fantastic topic. So I'll let you go ahead, Tim.
Cool. Thank you so much, Danielle. And thanks everyone for joining. I'm going to try not to look at your messages in the chat too much because I have limited brain power. So Danielle will keep an eye on the chat and alert me if you're all spotting mistakes that I'm making, which you may do if I go wrong. So
by the way, if for those of you who are joining us on Zoom, you can pop like messages and stuff in the chat. But if you've got particular questions for Tim, there's a Q&A section, so you can pop them in there or the chat. But if you really want to get something answered, use the Q&A.
So I'm going to go ahead and share my screen and hope that this all works. Okay.
Yes, we can see your screen.
But yes, last minute this morning. Can you see my whole screen?
Yes, we can see Excel. Yes.
Perfect. So yes, last minute this morning, I remembered to put an about me section in the front. Very bad at marketing. So hello everyone. Yes.
Oh, okay. Hang on. How did you do that? I've seen this done before. This is.
Oh no, I just had this. I just had the rows grouped, and I ungrouped them.
Oh, okay. So just okay. There was no cool shortcut or anything there for it? Yeah, just a
no.
Oh, okay.
Yeah.
Cool.
First exciting Excel thing of the day. So yes, Tim Jacks. So I'm an ex-strategy consultant. I was a strategy consultant for a long time, during which time I did a lot of financial modeling. That was the thing that probably interested me the most about my job, mainly because it was probably the most painful thing about my job. And I guess, the most painful thing becomes the most interesting thing for someone like me who likes sort of solving problems. So now I run a company called Taglo, and we do financial modeling consultancy, audit training, and we also build software to do with financial modeling. If you want to know more about that, you can go to the website, taglo.io, or you can find me on LinkedIn. Let's get on with the actual session though. So before I actually get into some of the content, I want to tell you a bit of a story about one of the worst modeling experiences I've ever had. It's always a good place to start, right? And this particular one was, so back when I was a strategy consultant, we were working for a telecoms company. And they were a company who sold connectivity services to business. So, like your broadband provider, but for business connectivity. And they wanted us to model volumes and revenues of their products in a new market that they were trying to target. And they wanted the model to be quite granular. So they wanted to break down the volumes and revenues. So firstly, they were saying, well, we need to know for all of our customer segments, what are the volumes and revenues? And they had 5 customer segments they wanted us to look at. So they have private customers, different sizes of those customers, and they also have public sector customers, and a couple of different sizes there. So that was a total of 5 customer segments they wanted us to look at, and that's fine. And that just means when we're building our model, instead of having a single volume line or a single revenue line, it means we've got 5 lines for volume's sake, and it looks like something like this. And that's something we can sort of cope with and reason about fairly easily. But they didn't stop there, because their business, they also had different ways of selling their products. Sometimes they sold them directly to the customers, and sometimes they sold them indirectly, so through a reseller. And again, this is quite important to their revenues, because when they sell indirectly to a reseller, that third party takes a percentage of the revenues, so it has a different impact on their business. They wanted us to take that into account. But that meant sort of for every customer segment, we had to use 2 sales channels. And now we were looking at 10 lines for every calculation in our model. It looks something like this, where we have a mixture of segments and the sales channel all together. Okay, but they didn't stop there, of course, because they have a few products. They don't just sell, say, fiber, your normal fiber broadband. They also sell geeky telecoms things like Ethernet, wavelength. You don't need to worry about what those are. We're like, okay, we'll model separate products. What products do you have? We're like, well, 15. Fine, okay. And this is a mixture of different products and also different speeds of those products. And so we need to model the revenues for every single segment across both sales channels across 15 products. Now our calculations look something like this. And this now isn't fun. If I want to view an entire calculation at once, well, I can't, unless you have very, very good eyesight, which most of you probably don't. So, of course, we didn't lay it out like this, and there are different ways of approaching that. And we're going to talk about some of those later. But they didn't stop there, because the way they wanted to model the volumes of their business is to reflect some of the realities of how these telco products are sold. So I won't go into the details, but essentially, when a customer comes to the end of their contract after, say, 2 years, they might want to switch from one product to another product, or they might leave the company altogether, or they might just stay where they are. And so they wanted to know, for every product, essentially at the end of the contract, what's the likelihood of someone moving from that product to any one of the other products? And that essentially means for a particular set of calculations, you need to look at the products twice. And that means you have a total of 2,250 lines for every calculation you're doing. And that would look something like this, which is obviously very, very silly. And bear in mind,
oh geez, yes, I'm with you. I feel your pain. Yes, I have been there.
So I'm using some modern Excel, some dynamic array formulas to make some fake pretend calculations here. But in reality, of course, we had to build this manually, and it was well before the days of dynamic array formulas. And of course, we didn't have calculations that reached 2,250 lines. What we ended up doing is splitting our calculations across 10 separate tabs. So what we said is we'll have 1 tab each for a customer segment and a sales channel. So effectively, we'll remove those, which means we now have to deal with 225 lines of calculation, but we'll do those on 10 separate tabs. Now, that makes your calculation a bit more manageable. You can scroll through 225 lines, but it also means you have to deal with things like, how do I get the information into the correct tab? How do I get the information out of the correct tab into the outputs? And how do I make sure all those tabs are always up to date when we change the way we're doing the calculation? And I don't know if people want to comment in the chat on the percentage likelihood that there wasn't an error in our model. But I mean, I'll put it out there that it's probably not very high. I very much doubt we managed to pull it off without there being a single mistake in there. So that's just to set the scene about what can happen when you're working with dimensions. And we're going to look a little bit more into some of the details of how you cope with these kind of issues and the kind of calculations we do. Before we get into that, I just want to talk a little bit about the example that we'll be looking at today, which is based on an FMI case study. So the FMI is the Financial Modelling Institute. They run an accreditation program where they start with some foundational financial modelling concepts. There's an advanced financial modeler accreditation, which I did last year, which is a 4-hour exam, sort of testing your ability to build sets of financial statements. Then there's a chartered financial modeler accreditation, which tests a broader range of financial modeling skills. And then finally, there's a master financial modeler accreditation, of which only a few people in the world have that, one of which is Danielle.
Me. Yes, 8 people in the world have got that. So this case study was inspired, or this topic was inspired by one of the level 2 examples, wasn't it? That's what you're going to show us.
That's right.
Yeah.
So yes, I started working through the CFM program earlier this year. And in fact, the very first topic, which is, so these are the topics in the CFM. It's a bit funny. Like and the very first topic, yes.
12 topics that could possibly be tested. And I think there's 3, you can pick 2 questions out of 3. Is that still the case?
It's something like that, yes. So yes, I'm not quite sure. They give you 3 questions. I'm not actually taking it this October because I haven't had time to do all the work I need to do. Sorry, everyone. But yes, so you have to learn, well, you don't have to learn 12 topics. There are 12 topics. The exam will select from a number of those topics. It might be 3 or 4, and you'll have to answer 2 or 3 questions within those topics. And, they cover a wide range of areas. And the first topic is revenues. And typically what they're looking for here is things that make calculating revenues more complex than it might otherwise be. And sort of one of those things is looking at dimensions. And so we'll look at some examples today. We're not going to do a case study walkthrough of the case. That would take far too long. But we're going to look at my solution to one of the examples and how I've applied some various techniques in that solution, which are applicable, in many, many places. So this is the kind of case study that you get from the FMI. It will be some context about the business. They'll provide a worksheet with some assumptions already in there. And then they'll give you a task to build out say here that you have a task to build out some monthly sales projections and specify some outputs that you have to come up with. So we're not going to go through the detail of this, but I just want to emphasize, so this case is very much about the use of dimensions. So it's about a fashion boutique, an apparel brand, and they have a few product lines, women's, men's accessories. They have some existing stores across 4 locations, Paris, Milan, Madrid, and UK. And they're also building out 4 new stores. And they also have a range of currencies across those stores. And those are sort of the dimensions that we have to look at when solving the case study. So we're going to be looking at that a bit more in the details of this session. But before we do that, let's step back a bit and just clarify what I mean when I'm talking about dimensions to make sure we're all on the same page. So let's hope my conditional formatting works here. Okay, dimensions represent granularity in your model. So yes, whenever we're talking about these things, we're really talking about the level of granularity that's in your model. And that might be product lines, customer segments, internal departments. It really could be anything where things are repeated across your model. And you really use dimensions when you want to calculate something the same way across each of those items. I'll sort of show you why that's important in a couple of examples. So this is how you might calculate something without dimensions, and this is sort of my terminology, really. It's not necessarily a standard terminology with word dimensions. And so imagine a business here where we're calculating revenues for a product that has 3 different tiers. So it has a basic tier, has a standard tier, and it has a luxury tier. And what you could do in your model is you could calculate all these things separately. So you have a section of your model where you're calculating basic revenues, a section where you're calculating standard, and a section where you're calculating luxury. And later on, you'll combine them all. In my head, sort of, this isn't really working with dimensions. It's just sort of doing things multiple times. Whereas if you use sort of structured dimensions in your model, you'd lay it out like this, which is where you say, well, actually, the basic, standard, luxury are all sort of different items within the same dimension. And I'm going to perform the calculation for each of the items within that dimension in exactly the same way. And so all our volumes are together, all our prices are together, and all our revenues together. And we'll look at some of the pros and cons of using this approach. And the main sort of point to remember when we're thinking about these pros and cons is that models are communication tools. I hope Danielle will agree with that.
Absolutely, for sure.
So we often think when we're doing this kind of modeling, particularly when we're getting into complex things like this, where we have lots of granularity and we're starting to build up big, complicated calculations, that our biggest concern is getting to the right answer. But you always have to remember, what's that answer for? Who's going to be using that answer? Normally, for 99% of models, that answer is going to be used confidence in that answer and wants to understand, how did someone get to that answer? And therefore, your model needs to be, transparent and understandable. And that's one of the main pros of dimensions comes in. So in my mind, it's much more transparent. So what you're saying to the user or to the reader by laying out your model like this is that these calculations are all done in the same way. You don't need to go through and check that they're using the same approach, because otherwise, why would I have grouped them together in one sort of block in the model?
And of course, the use of dynamic arrays make that so much less likely for there to be an error, because the calculation will just spill across automatically.
Yes, yeah. I mean, we'll definitely come back to dynamic arrays in a bit. Yes, and whereas if we go for the sort of the other approach, you might be able to infer that these are all calculated the same way. You kind of need to go through and check that they are, if you want to be confident. And especially if you can imagine, if this wasn't 3 tiers, if this was the 15 products we were looking at before for the telco company, that then makes it a lot harder to go through and make sure they are actually all being calculated in the same way. So transparency is really important. It makes it much easier to maintain. I should be able to write this formula once and paste it across the whole block. And it's also easier to aggregate, which is a real benefit when trying to do this kind of thing. So if I'm aggregating if I'm aggregating the revenues in a model like this, I will need to separately, sum up all of these items. And fine, while it's okay in this very simple example, you can imagine if I'm doing a sum across a large spread out rate set of items, that is a clear point in your model where you might have an error. Whereas if I'm doing the equivalent thing with dimensions, all I have to do is add a single line here. And I have my answer in one place. And it's also much nicer for the user to look at as a reader, because they can see my total revenues is here. It's very simple for them to see this is the sum of the items above it. So again, it's clear, it's transparent, and it communicates well to the user. Okay, but there are a few cons of dimensions. So well, we've already seen that. Size of calculation blocks. So this can make your calculation flows harder to read. So if you can't even see on one, on the size of your screen, if you can't even see the whole calculation, then it's going to be quite hard to be able to if you imagine this was referencing two other calculations above it somewhere on the screen, how do you sort of follow that calculation through? It's going to be quite hard to do. And you do have sort of less flexibility. So again, because we're saying by the way we've laid it out here that all of these items are calculated in the same way, it also means, well, what happens if you want to calculate one of these items in a slightly different way? How do you cope with that situation? So you potentially lose a bit of flexibility. But there are some good solutions, of course. So one thing to do, if you have these very large calculation blocks, you can split dimensions across tabs, like we talked about. You can make your blocks more manageable size, but definitely increases maintenance difficulty, and I would advise avoiding that where possible. You can break out a single dimension item for bespoke calculations. So let's say in this example, we actually have a different way of doing pricing for the luxury tier, and we have some sort of discounting for luxury pricing, which I've hard-coded in. Don't ever do that. It's just an example. In which case, fine. What I would do is I would split out the luxury pricing here, but I would make sure that I want all my pricing to be in the same place again before I calculate my revenues, so that my revenues can all be calculated consistently. So I have an extra aggregation step in here where I pull together the items from the different places that they come from. So basic and standard are coming from one place and the luxury pricing is coming from another place. And I make sure I communicate it to the reader that, by the way, these come from different places. Don't copy and paste across all. So you can't sort of really over communicate when you're building this kind of thing. And or the alternative to that is you just always model for the most complex item. So we only needed to do discounting for the luxury, but we could have also done the discount calculations for the basic and standard tiers as well. We just use a 0% discount instead. And that's probably a better solution in most cases. And lastly, the other solution, don't model it. Okay, so in software engineering, we often say the best code is no code, because there won't be any mistakes in it. So I think, do I really need to model this level of detail? Is the granularity of output worth? That's the end of that sentence.
I've not heard that one before.
Best code is no code. Oh, yeah.
Good one, yeah.
Yeah, is the granularity of output worth the cost in transparency and maintainability? So it's something that's really important to think about. Okay, so that's sort of the dull ground and rules and concepts. And now we'll start to get into a bit of the implementation and how we do some of this stuff. So the first thing to look at is tables and named ranges are your friends when you're using dimensions. So
yeah, I noticed that you've used named ranges quite a lot, which I know some people are often not that keen on, but I think it can be quite helpful the way that you use them. Yeah.
So I mean, people are very welcome to disagree with me, but they'll have to go some way to change my mind anytime soon on this.
Yeah, no,
so
no, we're getting named ranges, love named ranges, yeah.
So for instance, the very first thing I do, for instance, when solving this FMI case study is, I look, what are the dimensions involved? The first one here is the product categories, women's, men's, accessories. And I will start by, on a separate tab in my model, a dimensions tab or something, I will put these into a list, women's, men's, accessories. And then I put them into a table. So insert table.
Tables with a named range, lovely.
Yeah. And I try to make them look nice. There we go. And give your table a nice name. So in the table design table, you can enter the table name, table product lines. And this means we can now reference by referring to the table. And that gives us our dimensions whenever we need them. Now it's a bit, that's quite a lot to type. So which is why I normally use a named range as well, but a named range within the table. So if you select just the values in the table, then you can type into the named range box here. And now I can just type
shorter. Yeah.
product lines instead. And this has a few sort of obvious benefits. First thing is that we can add items to our table and they'll automatically flow through. Now, unless you're using dynamic array formulas everywhere in your model, which you're probably not, that won't actually update your calculations, but it will at least help you with, potentially some of the labeling in your model. And again, we'll look at some more of that later.
Because of course, you can't really put dynamic arrays inside a table, but when you're doing what you're doing here, which is just for entering the different dimensions, it's a really good solution. And I just also wanted to just point out the difference between a table name and a named range, kind of similar, but two slightly different things. And so what you've demonstrated here is creating the table and then creating a named range on top of the table. And Anton has commented that he uses the prefix TBL to distinguish, to show what's a table and what's a named range.
Yeah, and it's generally, it's good. So I use the prefix table, but people who don't like typing the full word table use T or TBL.
I use T,
I should probably change my practice there. The other thing is we can now change, the name of an item within that, and it will update hopefully in our model. And the other really good benefit is that we can now use data validation when we have our dimension as an input to our model. So if we do data validation, you may not be able to read this, but I'm using the allow list source equals product lines.
You can zoom. People can zoom on that if they can't read it. We can't.
Then I now have a drop down I can use. I now have a drop down I can use to select those values. So that's why it's really useful to use tables named range, enter dimension names once reused, change the dimension value names, which changes everywhere. It allows you to use validation drop downs, but note, if you are using those drop down validations, those values are then hard coded in the model, so they won't automatically update if you change the dimension name, and you just have to keep an eye on that in your model. The other sort of fundamental.
But if you use a named range, that will expand, won't it? If you create a named range, use that in the
if you add a value, it will then the list of values in the validation list will expand. But if you've selected a value using that list and then you change the value in the original,
of course.
it won't update. It's not a direct reference. Okay, so just a little bit about formula consistency. So I'm going to go over to the solution for the FMI case study now. And we'll just have a look at one of the output lines, which is where we've aggregated all the revenues up by the different lines, those women's, men's accessories. And what you often pay a lot of attention to when building your models is that you always want to be able to copy and paste your formulas horizontally. Like I think we have a lot of practice in doing that. So you should be able to pretty much in all situations copy and paste your formula across the entire date range of your model. And that means basically, yes, can you copy and paste your formula horizontally? When we're using dimensions, we also want formulas to be consistent across dimension. And that means, can you copy and paste your formula vertically? So in this situation, for instance, what we have above there is we have revenues split by the line and the store. So by women's, men's accessories and by the different stores in their business. And of course, we want to add them up. So, one thing we could do is just add them up using a sum. And this is what a lot of people would do. But of course, that means I can't now paste vertically. If I do that, it's just going to go like this. And then I have to manually drag this down to the right place. Fine, you can do it. You can get the right answer. But the chances of you making a mistake are much higher. If you change something in your formula, do you remember that's how you have to do it or not? So what we want is formulas that enable us do like this SUMIF formula, which we'll talk about a bit later, which allow us to also copy vertically as well as horizontally, so that we can just copy and paste across the whole block with no mistakes. Dynamic array formulas are an option for ensuring formula consistency, like Danielle was talking about, if that entire block was a single dynamic formula. But in general, those are quite hard to do, and you'd need a level of expertise about dynamic array formulas, which people like Craig, who was on Danielle's meetup a couple of weeks ago, I think, will tell you a lot more about. They know a lot more about than I do. But I'm sort of showing you the old school ways today in general.
Yeah.
That said, let's talk about how to use dynamic array formulas for generating line labels, which is a really good place to use them.
Cool.
So this is where I'm going to show you a lambda that I've created. And I'm going to make sure this is on the screen for as long as possible so that people can access it if they need to. And I'm also going to put this while I'm here in the chat.
Can you pop that in the chat? Yeah, that'd be great. And in the meantime, I think Matthias is spoofing us or pranking us. What's the word? He says, "Why do you not use VBA instead of this heavy sum if?" I think he's being funny. We've also got a question from Rishi. Rishi Safra is actually going to be on one of our speakers coming up next month. He says, how would you perform a cross join of all dimensions if you get your calculation? We might leave that one to a little bit later, Tim, if that question is
that might be exactly what I'm about to talk about.
Oh, cool. All right.
Possibly. Okay, so firstly, right, so we have this okay, no, I mustn't look at the chat. Right. In order to, I'm going to introduce this lambda, and if you want to use this lambda, you'll need the Excel Labs add-in, which you can get from the Excel add-in store here. You can Google that if it's not clear. And once you're in the Excel Labs add-in, you need to go to the modules section here, and there's a little cloud sort of download icon. And if you put the URL that I've put in the chat into there, you can take add formulas to new module. I put it in a module called Taglo, because that's the name of my business. You can call it anything you want. Then you'll basically import all the lambdas that were on that URL, which is just one lambda. And it's lambda called expand dimensions. And if you put that lambda in without any arguments, you'll see some documentation here for what it does. But I'm going to show you what it does in here. Okay. So if we go up to the top of our model, and I now want to look at
the code.
I now want to look at the first item in this FMI solution. And the first thing to note is that, so what we're doing here is we have some existing sales across the different lines and for the existing stores that we want to base our sales on for our new stores. Our new stores in different locations. And we're basing the new store sales, New York, Montreal, Zurich, Moscow, on the sales from our existing stores. And the first thing to notice here is that my line labels are important. If I delete them, my calculation breaks. Okay. And that's because we're doing things with lookups, which means we're referencing the labels. So my labels aren't just there for, to be pretty. They're actually being used in their calculations. And so, it's important that we're able to put the right labels in the right place. So we could, of course, do that manually. I don't think I need to explain to you that that's boring and error prone. And so what I've done is create this lambda to help with that process when you want to, particularly when you have two or more sets of dimensions and you need to create maybe the cross join that was being asked about. I think it's sometimes called a Cartesian product as well. Those are just geeky terms, so all the combinations of those two dimensions. And so I'll quickly show you how the formula works. So the first thing is you have to use the HStack formula in Excel to create the input to the lambda. All HStack does is combine two different arrays together, two different vertical arrays together. So my first array is going to be my first dimension, my existing stores. My second array is going to be my second dimension, the lines. And that gives me something like this. This is now the input that I want into my Lambda. And what the Lambda does is it says, okay, for everything in here, it's going to create all the combinations of those items. So I can put that within the Tableau expand dimensions. And now I get all those labels listed out in the right way. It works for an unlimited number of dimensions. So if I were to add another dimension in this model of currencies, I would get all of those listed out like this. Let's undo that. There's also an argument to change the direction that they move from. So now store is changing every line, whereas before the product line was changing every line. And if you're creating an output sheet and you just want some labels in a single column to look nice, you can use this delimiter argument, and it'll put them all in one column like this. Now, that wouldn't be useful when you need to reference those items in a calculation, like we were doing before. It can be useful otherwise. So let me just put that back in here, unbreak my model.
Nifty. Don't you worry about there being, going down further, because of course the dynamic formula doesn't handle things being in the way very well. So do you not worry about having, giving it a bit more space down below?
Well, I mean, okay, so yeah, I guess the question is, what happens if I add something to here?
Yeah.
Then everything will break, right? Yes, and we get a spill error. And yeah, that's a concern. But I think, whatever way you were building the model, if you weren't using dynamic arrays formulas, you're always going to have to add lines. So, in that case, I'd have to add some lines, but then at least I guess, you get a clear warning that something's happened and it gives you an action to do something about it. So
whereas if you weren't using dynamic arrays, it would just kind of miss off the last little bit, which is not great.
Yes, and you just might not remember.
That Lambda Peter says that Lambda is truly magnificent. It certainly is. It's great.
Okay, well, there you go. If you had a bit of help from ChatGPT to build it, I won't lie. Although it couldn't actually build the Lambda, it could just tell me how to build the Lambda, and I had to do it myself. So yes, remember line levels might be used in calculations. They're important. Okay. And now some calculations. We have about 20 minutes and got about 15 minutes worth of calculations, but we don't have to go through them all. But we'll start with some basics. So I need to look at, okay, 2.2.2. So in this section of the model, we're doing something fairly simple, which
sorry, Tim, just a great question from Jessica. Are you allowed to bring lambdas
into CFM exam? Yeah, I don't know the answer to that question.
Sorry, Tim. Can you hear me okay?
Yes, I can see the question. I don't know the answer to that question.
I believe you can, as long as you can write it during the exam. You can't bring it in.
That's probably true, yeah. Okay, so in this example, we're doing a fairly simple lookup. We have exchange rates by currency. We have stores, and we want to find out the exchange rate for that store based on their currency. So there are a couple of ways of doing this. The first way and the most common way these days is to use an XLOOKUP. Probably a lot of you are very familiar with this now, but I'll just show you quickly what we're doing. So with an XLOOKUP, we have a value we want to look up, which is going to be our currency. There's an array we want to look it up in, and there's an array we want to return a value for. And if we do that correctly, it will look up the correct item. Okay. So XLOOKUP is, when you're looking up a single item, XLOOKUP is usually the go-to tool. Now, Danielle, interestingly, recently went to a part of the world where her customers didn't have access to a version of Excel that had XLOOKUP, in which case those people will have other options. My go-to option in that case is to use index match. If you want to understand index match, the best way to understand it is to first do the match part of your formula. And all these things is we're looking something up. So what do we want to look up? Where do we want to look it up? And what do we want to return? With a match, we're looking up, again, we're looking up the currency. That's a lookup value. We're looking it up in this list of currencies. That's a lookup array. And a match type is 0. We want an exact amount. And that tells us, for each of these items, what's the row of the relevant item in that array. So it's 1 for Paris, Milan, and Madrid, where we're looking up euros, and then a different row for the rest of them. And all we now need to do then is to wrap that in an index formula. And an index formula takes an array that you want to get a value from, and you say, which row do I want? And we've already worked out the row. That's our match. And that will give us our results. So I'm not going to dwell on that too much because there's all kinds of content out there on the internet about index maps and that kind of thing. But that's essentially your basic lookup. And then we move on to summaries, which is really important when you're doing dimensional modeling with a lot of granularity. You always want to sum stuff up at the end. And we looked at that earlier when we saw all our outputs, which was revenues by line and store, and we wanted to total them up across the lines. And remember, we want a formula that we can copy and paste across all the dimensions. So here we have a couple of options. One is sum product, which is something that I'm in the habit of using, but is slightly more complex. And one is sum if or sum ifs. But at the moment, this one uses a sum if. So sum if essentially does what it says on the tin. It says sum stuff together if something is true. I actually find the way it's laid out a little unintuitive, but maybe that's just how my brain works. So zoom in a bit. Sum if, here you select first the range that you want the criteria for. So I select the product line range. I select the criteria that I want to evaluate against that range. So I'm saying I want whatever rows in this range are equal to my product line here. And then I select the things I want to sum up. And that's my sum if formula, and I can copy it vertically, and that gives me answer. And I want to raise here that it's really important when you're using these dimensions, always, where it's relevant to add things up, always put a total line at the bottom, because it's really important to be able to check visually that you've managed to catch everything when you're summarizing things up. So I can see instantly, I've got the 1,000,003 output here and the 1,000,003 output here, and copy those across. Okay, for those of you who like some products, it is worth just showing you a little bit about how some products work, because the concepts are can be quite transferable and allow for a lot more flexibility in certain situations. So it's good to think about how Excel thinks about what I would say conditions. So when is something equal to something else? So if I just select a range in Excel of labels here, and I say equals, that range is equal to something else. This is how Excel looks at it. It creates a list for every row in the range I'm looking at with a true or false. And when you have a list of true and false like this, you can multiply it by some other thing. And it will then provide you with zeros where everything was false and the value where it was true. These were already 0 in the input, which is why they're 0 now. And what we can do then is add them together. Okay. And so we've then got the answer. Oh, I've actually deleted it. So that was the answer we had before, 539,000. And all we've done there, if you think about it, is we've multiplied two things together, and then we've added them. So we've done a product, and then we've done a sum, and that's what a sum product is. A product, then a sum. So to use the same approach in the formula, we use the sum product formula. We select the thing we want to add up. And then we create the condition that we want to apply to it. And so here we can do just like what we did before. Select the product line. Say, I want the product line to be equal to the item on the left. Okay, so those of you who are sharp will know that this won't work. Turn 0. Because unfortunately, the sum product doesn't quite work as nicely as when we did it separately before. The trues and false that we create here won't automatically multiply by the values. So we have to force these to be 1s and 0s. We can do that in a couple of ways. We can do minus minus, which converts everything into 1s and 0s. Or we can wrap these in the n formula, which converts everything to a number. Or there are other things. You could just multiply everything together if you want, but this is the solution I prefer. Okay, and now we have, I've done something wrong. There we go. I've anchored these incorrectly. Always good to have checks in your model, so spot when you make mistakes.
Yes, that error check in the corner is it's great.
Yeah, I anticipated doing something wrong in this demo, so I've had that to alert me just in case. So that's that really, and the benefit of some products is that it's very, very flexible. So you can make these conditions whatever you want. They don't have to be something equals something else. They could be something is less than something. It can get very complex. You can use your imagination on those. But if you're doing something fairly straightforward, then some if, probably a bit more transparent to the user about what you're doing. Okay.
There's a great conversation going on in the chat about some product versus some ifs using the n. That's great to see all these. Neil Blackwood's got some good ideas on different techniques, which is great to see.
Okay, yeah. So multi-dimensional lookup. Okay, so this is an interesting one. So I'm going to go to was 2.1.1. Okay, so now we're looking at the bit of the pricing in our model. By the way, I should say, when you're actually doing this in the CFM, you probably wouldn't build as sort of long and detailed a model as I have. I've sort of done the gold standard approach. So, you probably won't be building a 1,000 line model or something, because there are lots of shortcuts I could have taken here if under exam conditions if I were going to. Just in case it's scaring any of you.
Yeah, and you certainly don't need to be. You don't need to be building a lambda to pass the exam.
No, for sure.
That's not necessary. No.
So here we have a list of currencies and a list of years, and we have some different inflation rates for each year. So this is a monthly model, which means we need to work out what the year is, and then we need to look up the correct inflation rate for that year, which is 0% in 2023. Maybe I should scroll across a bit to look at something more interesting. Okay, and to pick the right value. So this is now a multi-dimensional lookup. We're not just looking at one thing. We have to look up where two things are true, where both the currency and the year are the thing we want. So one way to do that is to sort of cheat a bit. It's not cheating. It's a perfectly valid approach. Is you create an index. So you create something that you can look it up in. So I could create a column here where I do currency and year, put them together, and now I have something I can use an X lookup formula in, just like we did before. So I can look up, I have to create the same thing that I did here. I have to do the currency and the year. I select my lookup array, and I select the array of the items I want to return. Okay, and that should give me the correct values, yes. But there are some situations where you might want to do this. Maybe you don't have column. Inserting columns into your model can be a bit of a nightmare, something you don't necessarily want to do. It can get a bit messy. So there's another approach which I like to use, which is you can use a normal X lookup. You just have to be a bit clever about it. So again, we come back to the idea of how Excel looks at conditions when you compare things. So if we think about the kind of thing we were using for a sum product, we can do the same kind of thing here. So if I just start typing in here, let's set up our conditions. Well, we want the currency be equal to, I'm going to pick the second row here. It's a bit more interesting. So we want the currency to be equal to GBP there. And we want the year, and remember we're using multiply to do this. So this is the equivalent of doing the product thing we looked at before. So we multiply our conditions together if we want to combine them. And so we look at the year is equal to the year down here. Now, how does Excel think about that? Well, it thinks about it in terms of trues and false values. And because we multiplied things together, it's going to convert them into ones and zeros. So now we have a nice array which has zeros everywhere, except it has a 1 in the exact row we want, pounds in 2022. So if you think about it, this is now something we can look up a value in. What value do we want to look up? Well, we want to look up the value 1. So I can now, in here, use an XLOOKUP formula where I'm looking for the value 1. And I want to look for the value 1 in the condition I just set up. Do it again quickly. Multiply by year condition. Left out bracket. Year is here. So I'm looking at 1 in that array of ones and zeros we just created, and I want to return the value of the inflation here. And that will give me the correct answer. So that's sort of slightly counterintuitive. And again, it fails a little bit on the transparency test, perhaps, because it won't necessarily be obvious to a user what this formula means. What does looking up 1 mean? But it is a sort of a good solid way of writing the formula, if that's what your aim is. Just check for time. How long have we got left?
Yeah, just a couple of minutes, really. But okay. We've been able to keep on top of the questions as we go through, so we don't have any outstanding questions. So if you want to keep going. We do. Robin's asking, why not use a nested lookup? Yeah, you could quite possibly go. There's a ton of different solutions. Tim's just shown one example of how you could approach it.
Yeah, I mean,
but yeah, any questions? Now is the time. Otherwise, we'll probably have just enough time for a little bit more.
I mean, I have got an example of a nested lookup here to show you. So, of course, it's Excel.
Yeah,
so,
cool.
So you can, there are always more solutions in Excel. So you could use a filter formula, for instance, if you're using sort of dynamic arrays. You could also use a sum product, where effectively we're doing what we were doing before. We're just adding together the items that match. And if only one item matches, then that's fine. The downside with the sum product formula is that, again, transparency, you're kind of telling the user that you might be adding multiple things together when actually you're not adding multiple things together. You're just looking for a single item. So, it's all very much horses for courses. I've showed you sort of my preferred ways of doing things, and there are always going to be other things. I will show you a quick, slightly more complicated nested lookup. So let's go right back to the first thing we looked at in the model, these looking up these base unit sales from the existing stores. So what we want to do is we know we want to look up a single value. So we're going to use an XLOOKUP here. And we want to look up, so we're going to use this one approach again, or that's what I'm going to do. That's my approach here. So I'm going to look it up and I'm going to create the conditions that I want to look it up in. So the first one is easy. It's, I'm going to look up where the line dimension is equal to our line here. And the second one is, oops, sorry, I need to unfreeze panes here so we can look at this. First one is straightforward. I'm going to look up where the line dimension equals my line here. And the second one is where my store equals what? Well, it's not the store here, because first I need to convert New York to the relevant store. The relevant store for New York is London. So here I have to do another lookup, this time a normal lookup, where I'm going to look up my new store in this array. I want to return my old store that I want to look up in, and that will give me the correct thing to compare the previous existing stores to. It's very hard to put these things into words.
Yeah.
Those are my conditions, and then I want to return this array. So essentially, the message is, find a way that works. Find a way that works with your brain and how you like to think about it. This is how my brain likes to think about it. I like to think, if I'm looking up a single thing, I use an XLOOKUP. If I use my XLOOKUP one approach, then I know that all I need to do then is say, well, what are my conditions that I'm looking up that one in? I put the conditions together and build it up like that. Now, you don't have to build complex nested formulas like this. You could also just use more lines. That's always an option. Lines are free, I like to tell people. So I could put in another set of lines here where I just look up the store here. So, based on the store, and perform your lookup here. I'm not going to do it, so that I have a list of London like this. And then rather than using the X lookup in here, I would just link to my store here. And for some people, it's much better to just have more lines in, do things in more steps. Makes it a bit easier to digest, a bit easier to think about. Okay, and with that, that's the end of my content.
Yeah,
a couple of minutes
thank
to
you,
go.
Tim. That was fantastic. That's really good, and I really love the way you show the different approaches, and I think it's a really important message that there's no one way to pass these types of exams. It's really just about choosing the method that makes sense to you and then being able to execute it under exam conditions. And I think that's what people should really remember from this. Did you say that you were able to share this file, or is that part of the CFM?
So I can share. Now, I don't see a reason why I can't share. But I can't share the case study brief and
inside
their solution.
If you're enrolled, if you're enrolled for the CFM, you will have access to that.
Yeah.
But if you email
I'm happy to
Tim,
share
I can, send
my
that
solution document.
Okay.
And I'm happy to share, this if anyone has any interest in my notes here. Share those as well. Although obviously you can read those all on the YouTube video if you want to as well.
Yes, and we will show. I will send it in the email, the LAMBDA as well. I'll send another link to the LAMBDA to make sure that everybody has that. So yes, all of the things that we talked about, I'll pop those into the follow-up email, which you will get tomorrow. So thank you, everyone, for all your fantastic contributions. I love seeing all of the comments and all of the different ideas and things that people have in there. And most importantly, thank you so much, Tim. That was fantastic to get a little bit of a peek inside your mind and see how you solved this exam question. So thank you so much.
Well, and thank you for having me.
We'll see you all again.
Thanks to everyone for listening.